Hi everyone and welcome to our CAD programming lessons. For today I'd like to speak a bit about Docker and how to build OpenCascade in a Docker container. People use Docker for different reasons, and the reasoning for me is sort of twofold. The primary reason of using Docker here is that I want my software to be sort of isolated, because Docker gives you kind of a sandbox, and whenever you deliver your software to your client, you can be sure that you will not have any missing libraries, and all the versions of all the libraries are going to be correct, so that you will not have any surprises on runtime. This is one reason. And actually I have another reason for using Docker, because sometimes you deliver not binaries but sources, and in such situations you want to have like a piece of documentation explaining how to build things from scratch, how to get all the necessary third parties, all the necessary libraries, and if you, for example, configure your project with CMake, you also need to document how to specify all the CMake variables with all their values and all these things. So basically here you can also take advantage of the Docker in a sense that you can deliver just like a Docker file, and Docker file is a script explaining how to build things, and you will have nice instruction, nice step-by-step guide which will be easy to follow. Of course, there are many other reasons of using Docker, especially for people who are dealing with microservice architecture or who are using like cloud computing services, but we're not going to discuss that a lot, and we will rather build OpenCascade image and containerize it, and we will build like a Linux image for OpenCascade, and then we will see how to run draw test harness there and to visualize a simple box shape. Alright, there we go, and now I want to show you how to prepare Docker file and how to containerize OpenCascade. So basically here I am running my Linux Ubuntu, and I'm going to use Docker from Visual Studio Code. For that, I'm going to run it first, like code, and actually here the first thing to do is to go to this extension tab over here and install this Docker extension, which is sort of, Microsoft certified extension for Visual Studio Code. So once you have it installed, you can use Visual Studio Code for all Docker oriented things, and you can actually do everything about Docker without leaving this Visual Studio Code environment, so you will not even have to run terminal window. Alright, here in Visual Studio Code I have desktop as my working directory, and now I'm going to create like a Docker file. So let's have one. And you see it's just an empty file so far. And now we are going to fill it with some contents. And basically people start from some basic image, which is very often Linux Alpine, but okay, Linux Alpine is a good thing because it's a very thin and lightweight version of Linux, and it's very fast to deploy. But there is one problem with Linux Alpine, and the problem is that OpenCascade is simply not going to compile on Alpine. Actually, if you want to use Alpine, you still can go and patch OpenCascade, and that's not a big deal actually, but let's not waste time on it. And I will going to use another image, which is going to be Ubuntu, then latest. Now I want to put here some magic variable, which is Debian, frontend, then non-interactive. This thing, this environment variable, is going to force the system to accept the default answer to all the questions which might show up. So let's keep it like this, and that's pretty standard thing for Ubuntu images. And now we are going to get prepared. Now we are going to download the package list from the repositories and update them to get information on the newest version of packages and their dependencies. And for that we go like run apt get update. Now we are going to get prepared to development, because we are going to compile things with C++ compiler. We need linker, we need compiler, we need Git, we need CMake. So let's get all these things. For that we are going to go like apt get, then -y to answer yes to all the questions which might show up, and then we go like install, and we install all the build tools. And here we start from build essential, which is a collection of compiler, linker, and all the libraries which we need to compile a program. So This is a necessary thing, and then we install also Git and CMake. So like this, we have everything we need to build OpenCascade. And now we can proceed with the dependencies of OpenCascade. But before we go for that, let's just try to build this image right away. So here I click this build image in the context menu, and then I need to specify the image name, which is in my case going to be OpenCascade. And then I have this tag for version, which is 740. So let's let Docker to build this image. And what I forgot to mention is, of course, when you are doing all sort of experiments like this, you need to have Docker installed on your machine. So this is something which I did not show in this video, because actually I would suppose that you will find all the necessary information about Docker and how to install it on the internet, because actually there are tons of resources and tons of documentation about this Docker thingy, so let's not waste time on it. And now, while our image is being prepared, we can go ahead and install all the dependencies of OpenCascade, and we are going to start with TCL and TK things. So let's go like run apt-get install, then TCL, then development version of it, and then TK and TK dev as well. So in a future version of OpenCascade, TK might not be necessary, but since we are going to use OpenCascade 740, we still need TK thingy here. Then we need something related to X Windows system. We need to have xlib. It seems like you see that what is going to happen then you make a mistake with this environment variable. Here you need, of course, to fix this typo and have this front end, and if you do not do this, then you are going to have this sort of problem, because here from this state of building you can do nothing actually, because it's sort of frozen in this state here. So the only thing I can do about this, I can like kill the active terminal instance. So now I can repeat the process, but let's try first to have all the dependencies in there. And since OpenCascade is, after all, it's a graphics, it's computer graphics library, we need to install something related to OpenGl, because in our image there is nothing related to OpenGl, there is no OpenGl driver. So let's go and install few things which are necessary. The first thing is a portable library for OpenGl. Then we have like free implementation of OpenGl API. And then we have like headers and static libraries which are necessary for compiling programs with GLU. And okay, I think that this image is going to be better than the previous one, so I can go ahead and build this image right away. So while it's being built, we can go ahead and clone OpenCascade repository. So we go like run, then git clone, and then we specify HTTPS link, which is sort of public link. You don't need any credentials to access OpenCascade like this, because it's a public GitHub repository, github.com, then open-cascade-sas, and then OCCT git. And we can give this working copy like a folder name, let it be OpenCascade, why not? And then we change our working dir to this /OpenCascade, because what I'm going to do now is I'm going to check out a branch with a certain version of OpenCascade. So I go like git checkout, then I give it like a tag name, which is going to be 7_40, and right away I'm going to create a branch just to avoid having some, extra warnings saying that I have a sort of detached state of my Git repository. So if I want to avoid these things, then I can create like a test branch right here. So actually you can type just any branch name. All right, so you see that my image is already prepared, and now since I have some few other steps which I have added, like cloning this repository, I can prepare another image, and this building procedure is sort of incremental. It's going to start from the last instruction, so actually here you see it starts from cloning the repository, and it's not going to reinstall all the third parties, all the products I have specified here. So that's a big deal actually, because it saves a lot of time. And now we are going to have this working copy of our OpenCascade repository, so we can go ahead and try to configure OpenCascade with CMake. And for that we start from from creating a build directory, which is going to be like build. And now we change our working directory to this, OpenCascade/build. And from here, from this working directory, we can finally run CMake, and we run it like this. We run it from the one level up directory, because this is a directory containing sources. And now we are going to define all necessary CMake variables, all starting from -d. So we can go like CMake build type, which is the first thing to define. And this is a pretty important thing, because if you forget to define this build type, then you are going to have some problems at installation stage. And another variable we are going to define here is CMake install prefix, which is effectively the target directory where OpenCascade binaries will be installed. So I'm going to use just system usr folder. Should I have something else? Let's keep it like this. Let's keep it simple. And finally, I'm expecting that after this, of course, I have to type CMake here. After CMake has configured all my make files, after CMake has generated all my make files, I am ready to run make and run make install. So this thing. So okay. And you see that this image is also ready, and now we can go and try building another image, which is going to compile the whole thing. Okay, you see that there is some problem with install prefix. Of course, I forgot C here. Yeah, there is something is wrong with me today. Yeah, let's try this. Okay, you see that finally we have our compilation process in progress. So we have to wait for several minutes or so, and after that we will be ready to run our Docker container and to see something in action. Alright, so we have our image prepared now, and we can go ahead and try to run Docker. So for that I'm going to run new terminal window, and from here I type this docker run, and for interactive use I'm going to give it like a couple of arguments. First of all, I need to pass like, you know, terminal and I to keep my standard inputs open and all these things, and then I have to bind this my Docker to X server, which is sort of running on my host system. For that I go like net equals host, and then I defined like environment variable saying that my display is 0, and then I give it like an image name, which is in my case OpenCascade then tech. And you can actually go there, clicking this whale icon, and you will see all the images you have. So I have this image for OpenCascade. If I expand it here, I see that it's actually this one. So I go like OpenCascade then 740, and here we go. So basically you see now that my Docker is up and running, and actually I am inside this local Docker's file system, and I can check what's inside. So we are inside the OpenCascade build directory, and I can actually run draw from here. Why not? So we can go like usr, then bin, and then draw sh apps, of course. Yeah, and see, I have draw up and running. And in case, okay, let me close it for now. In case if you could not run it like this, in case if you have some strange, I don't know, errors coming from X server, whatever, make sure to allow connections to your X server going like xhost plus, and then you execute this docker run thingy. And I could even simplify things, because I can run my bash script already from here, from this docker run one-liner. So to do that, I just go like usr, then bin, then draw sh. Let's run it like this, and you see I'm sort of in my draw, and you see here this is a draw window, which is a TK based widget, and now I have prompt from draw. So actually I can load all the plugins in draw. I can make a box. I can ask what is a, okay, it's a solid, and now I can visualize it in different ways. So one way is to visualize it like this, and this is not OpenGl viewer, but still what we can do, So here, for example, what I can do, I can use different keys to rotate, to manipulate my scene, like up, down, then left, then right, all these things. But I can actually go ahead and initialize my OpenGl viewer. You see that there are some warnings, but we do not care of them because everything is still going to work. And now I can go like the display A, and then I can go here and actually I have my scene. If I press F button on my keyboard, it's going to fit everything to the scene, to the viewport extents, and then I can press S and it's going to give me this shaded view. So, and W for wireframe, and H is for HLR, which is hidden line removal. Actually, everything is up and running, everything is working smoothly, and we have our OpenCascade containerized. If we go here in this Docker extension tab, then you see, of course, that there are some containers on my machine. You see that I have one container up and running. Then I have all my images here, and then you also can have like a DockerHub account, and DockerHub is a place where you can publish all your images. So, for example, if I go here, I can run context menu and use this push action to publish my repository in my DockerHub. So actually that's pretty handy thing, because I can now log into my Windows machine and I can grab from there with my image and try running the same thing, the same container on my Windows machine. And if we go there, if we check what is inside this OpenCascade image, we see that okay, it's tagged like this, its operating system is Linux, and what else? So if I go there, I can also discover its compressed size, so it's quite a big thing, and it will be interesting to check the size of the same sort of image if we use Linux Alpine instead of Linux Ubuntu. But let's leave it like as a homework, why not, and we will proceed on Windows operating system right now. Alright, now coming back to Windows, I'd like to show you a couple of things more about all this Docker business. So you see here that I have this single remote repository, which is OpenCascade image. We see our familiar tag here, which is 740. We see that also we have this Linux operating system and its total size. So basically we can pull it right from here, or we can prefer using like command console instead. And basically there is one problem I'd like to discuss here, because it's not that trivial how to run UI applications in Docker container, and we've seen how to do that in Linux. We like used our X server and we reused our host system resources in order for the Docker to get access to this X server. And now on Windows we have sort of similar situation. So you see that we have this image here. If I go there to my locally available images, I can go and create like a new container out of this image. So if I push this run button, then I'm going to have this new Docker container running right now. So I can switch to CLI, to command line interface of Docker, and you see it's sort of up and running again, and we can check what is inside, and basically I can try to run draw just the same way as before. So we run it like usr, then bin, then draw sh, and you see here that it sort of runs, but it also claims that this application is not a TK application, and it immediately returns, and we cannot see anything actually. And the problem here is that this draw application, it tries to create a window, and since there is no X server running, it sort of fails, and this is something we have to fix. So I'm going just to stop this Docker container. I do not need it anymore. So yeah, here we go, we stop it. So basically the problem here is that we could not run this Docker container as simple as that. And in order to fix the problem, in order to have this Docker container up and running, in order to see this UI of our draw console, what we need to do, we need to do a small trick, like we need to install X server on our host machine. And for that you can use this X launch thingy, which you can download on the internet. And here, okay, we are going to run this X server, so we do some settings, some general settings over here, like I want it to create like multiple windows. Then we will start with X server without any client. And then one pretty important thing about this X server here is that I want to disable access control, so that I would allow all the clients, whatever clients actually, to connect to this X server. So click next and then finish. And you see that now I have this X server running. And basically now I can go ahead and I will just use this command console over here. So basically the first thing I want to do, I want to know my IP address. Here we go, it's this address over here, and now I can run Docker. And you see that the way I run it is pretty similar to what I did on Linux, because I still use this Docker executable, then run, and then, okay, this is a new thing. It means that if such a container already exists, I want to remove it first. Then for interactive run, I pass this combination of two flags, which is I and T. And then I still have to define this environment variable, which is a display. And then here I use the IP address, which I've got from ipconfig command. And then I specify the full name of my Docker image. You see that I also use this prefix here. It means that if this image is not locally available, it will be downloaded from DockerHub. So let's run it like this, and you see that I am getting into this command prompt of my local Linux machine, my local Linux image, so I can check what's inside. Let it be like, yeah, so we know what, okay, we are in the OpenCascade build directory. We see that there are all these familiar scripts, all these familiar things, and let's see what will happen if I run draw from here. So I am going to run it as usual, as usr bin, then draw sh. And here we go. So you see that now draw is running, and actually if I check it, you see that there is this draw window. It basically means that my X server was able to construct this window for the application, and I can use everything from draw. For example, I can go, I don't know, I can go to the samples and view all the available samples of OpenCascade here. And in modeling section there is one my favorite sample, NC101. This is a test case which we created back in 2015. So let's run this sample, let's see how modeling functionality of OpenCascade is going to work. And here we go. You see that this is a sort of realistic part with different features, like, you know, all those holes and pockets and even fillets out there. It means that basically we can run our Docker container, which was created on Linux initially, and we can still run it on Windows. We can just grab it from our DockerHub repository, and this is a kind of, you know, kind of amazing thing about Docker, because you prepare it once and then you can reuse your environment, you can reuse your application, and you do not have to care about how to rebuild it from scratch. You sort of containerize it, and it's ready to use. It's ready to be consumed on different target systems. Like here, as you can see, I'm running Windows machine, and I'm still using just the same Docker image. And maybe one last thing I want to show you for today is, again, I want to direct you to this GitLab repository, which contains all the source codes of all our lessons. And for our today's lesson, we have a dedicated directory here. And if you go there, you will find this Docker file. So you see that this Docker file, it contains everything we've done today, and also it contains some commands, so that you can refresh in your memory what we've been doing and what it's all about. At the end, I'd like to wish you good luck with Docker, and I'd like to stress that Docker is a pretty amazing thing, and it can really help you a lot in all your, you know, daily programming and deliveries and all these things related to DevOps processes, including CI and CD. And you can always get more information about Docker, because it's a very popular thing. It has got a lot of attention in the internet, so its community is large, and there are even people who call themselves like Docker captains, and it's basically another tool to be aware of. It's basically something which can ease your life a lot, if you use it properly, of course. So thank you for watching, and if you have any questions, then feel free to ask in the comments section below. And see you in the next lesson.